One of the most important aspects to achieving an accurate simulation in Bifrost is ensuring its attributes are set properly relative to your scene's scale. Failure to do so can result in simulations where not enough liquid is produced, or the effect of things like gravity or liquid density are either too exaggerated or too muted. Bifrost assumes a working environment where 1 unit equals 1 meter, while defining other values in SI units. An exception to this is temperature, which you enter into Maya in degrees Celsius, but which Bifrost converts to kelvins internally for use in its calculations. It's important to note that Bifrost's working units are independent of the working units of your scene. Changing the scale of your scene will have no effect on your simulation, i.e., it will still assume 1 unit equals 1 meter. Instead, you will need to adjust specific Bifrost attributes to conform to the size of the objects in your scene. When appropriate, the easiest method is to simply model everything to conform to the 1 unit equals 1 meter assumption. Doing so will allow you to use all of Bifrost's default values. As you can see, this model of a glass jar was built according to this scale, and as a result we get the expected pour. However, suppose we actually intended for this to be a model of a much larger vat, built at a 1/100th scale. In that case, we need to perform the following steps. In the Bifrost container node, recalculate the gravity magnitude based on this formula, replacing C with your scene's intended scale relative to the 1 unit equals 1 meter assumption. In this case, we're assuming our scene is built at a 1/100th scale, so C equals 100. Next, go to the emitter's Bifrost liquid emission physical attributes section. Use this formula to calculate a new liquid density value. Again, since C equals 100 in this case, our calculated density value is 0.001. Remember that the baseline value of 1000 is based on the density of water, so you may need to tweak that value if you're attempting to emulate a different substance. Now the simulation reacts as though we're pouring a lot more water into a much larger container, even though we haven't changed the scale of the model or emitter. In some situations, you may also need to be mindful of the time and transport stepping settings in the Bifrost liquid container node's adaptivity section. These attributes control the number of times that certain calculations are performed per frame. Higher iterations can not only help with simulation accuracy as a whole, but can even fix visible problems with simulations at smaller scales, or very fast particle speeds often caused by rounding. Just keep in mind that the more iterations you perform, the more computation cycles Maya will consume. Finally, the value you set for master voxel size depends greatly on the scale of your scene. Decreasing each voxel's size allows Maya to fit more voxels into the same space, thus increasing the liquid's resolution at the cost of performance. Simulation inaccuracies will be magnified at smaller scales in particular, so you'll definitely want to reduce this value when modeling smaller objects. Remember to always take this and all the previously mentioned factors into account when deciding on a scene scale.